Hey everyone, welcome back. Today we're working with systems of linear inequalities, and more importantly, how to shade the correct solution region when more than one inequality is involved. Let's start simple. Now, what if we have multiple inequalities? How do we know where to shade? Let's take our first example. We have x is greater than or equal to 2 and y is less than 4. First, let's graph x is greater than or equal to 2. That's a vertical line at 2. Since it includes equality, we draw a solid line. Now let's graph y is less than 4. That's a horizontal line at 4, and since it does not include equality, we draw a dashed line. Now let's decide where to shade. For x is greater than or equal to 2, that means all values to the right of the vertical line, so we shade to the right. Now for y is less than 4, that means all values below the horizontal line, so we shade downward. Now we look for the region where both conditions are true. That overlapping region is the solution. That's our answer. Now let's try another example. We have y is greater than 3x minus 2, and y is less than negative x plus 6. Go ahead and try this one. Let's start with the first inequality. The y-intercept is negative 2, and the slope is 3. So from the intercept, go up 3 and right 1 to get the next point. Since it's greater than, we draw a dashed line. Now for the second inequality. The y-intercept is 6, and the slope is negative 1. So go right 1 and down 1. This is also a dashed line. Now we have 4 regions. Which one should we shade? Let's analyze. For the first inequality, y is greater than the line, so we shade above it. That removes the regions below it. Now for the second inequality, y is less than the line, so we shade below it. The only region that satisfies both conditions is the overlapping section between them. That's the solution. Let's try one more. We have x is greater than 0, y is less than or equal to 5, and y is greater than 1/2 x minus 1. Start with x is greater than 0. That's a vertical line at 0, and since it does not include equality, we draw a dashed line. Next, y is less than or equal to 5. That's a horizontal line at 5, and since it includes equality, we draw a solid line. Now for the third inequality. The y-intercept is negative 1, and the slope is 1/2. So from negative 1, go up 1 and right 2 to get another point. Draw a dashed line. Now all 3 graphs are on the coordinate plane. So the question is, which region should we shade? We have several regions formed by these lines. Which one satisfies all 3 inequalities? Let's analyze. For x greater than 0, we need values to the right of the vertical line. For y less than or equal to 5, we need values below the horizontal line. For y greater than 1/2 x minus 1, we need values above the slanted line. Now look carefully at the graph. Which region is to the right, below, and above at the same time? There's only one region where all 3 conditions are true. That overlapping region is the solution. That's your final answer. Now let's take a look at equations in standard form. We have x plus 2y is greater than 4, and 2x minus 3y is less than or equal to 9. Instead of using test points, let's rewrite each equation in slope-intercept form. Starting with the first one, x plus 2y is greater than 4. Subtract x from both sides. 2y is greater than negative x plus 4. Now divide everything by 2. Y is greater than negative 1/2 x plus 2. Now the second equation, 2x minus 3y is less than or equal to 9. Subtract 2x from both sides. Negative 3y is less than or equal to negative 2x plus 9. Now divide by negative 3, and remember, when dividing by a negative, we flip the inequality. Y is greater than or equal to 2/3 x minus 3. Now let's graph both. For the first equation, the y-intercept is 2 and the slope is negative 1/2. So go down 1 and write 2. Draw a dashed line. For the second, the y-intercept is negative 3 and the slope is 2/3. So go up 2 and write 3. Draw a solid line. Now let's determine the shading. For the first inequality, y is greater, so we shade above the line. For the second inequality, y is greater than or equal, so we also shade above that line. So the solution must be the region above both lines. That overlapping region is the answer. And that's how you graph and shade systems of linear inequalities. As a quick recap, rewrite in slope-intercept form, graph carefully, and then find the region that satisfies every inequality at the same time. Keep practicing, and this process will become second nature. I'll see you in the next lesson.